Hello, welcome back to my channel. This video is for the fourth experiment titled Boolean Algebra. In this experiment, we will check the theorems of a Boolean algebra in practical approach and using those theorems to simplify the logic equations. In this experiment, we will be using the following materials: 7400 NN gate, 7402 N gate, a 7402 NOR gate, a 7404 hex inverter gate, a 7408 N gate, and a 7432 OR gate, a breadboard, a DC power supply, and connecting wires. For part 1, which is double inversion, we will be using a 7404 hex inverter gate. We will be building the circuit shown in this diagram. In the double inversion circuit, input logic is equal to the output logic. As seen in the table, if the input is 0, the output will be 0, and if the input is 1, the output will also be 1. If you inverse a logic 2 times, it will be equal to the original logic. This shows a Boolean equation of x equals a. For the second part of the experiment, which is absorption theorem, we will determine the logic output of an AND/OR and an OR-AND combination circuit. Using a 7408 and 7432 logic gates, we will construct the AND/OR combination circuits shown in this diagram. Output will only be in logic 1 if input A is at logic 1. If not, it will be at logic 0. Based on the data gathered, we can derive the Boolean equation to x equals ab prime plus ab, and by simplifying it, we will have an equation of x equals a. The diagram shown will be the guide for the absorption theorem of an OR and combinational circuit. The output will only be in logic 1 if input B is at logic 1. If not, it will be at logic 0. Based on the data gathered, we can derive the Boolean equation to x equals a prime b plus ab, and simplifying it, we will have an equation of x equals b. So if b equals 1, then x, or the output, will also be 1. For the last part of the experiment, we will check and simplify the logic equation using distributive law. The experiment lets us construct two circuits. The first circuit is shown in this diagram, and we will call it Demo 1. circuit gives us an output of logic 1 if only input C is logic 1, input B and C are 1, A and C are 1, A and B are 1, and all inputs are at logic 1. Otherwise, it is at logic 0. Based from the data gathered, we can derive the Boolean equation 2x equals a prime b prime c plus a prime bc plus ab prime c plus abc prime plus abc, and simplifying it, we will have an equation of x equals ab plus c. By using this diagram, we will now construct the other distributive law circuit, naming it Demo 2. The circuit gives us an output of logic 1 if only input C is 1, input B and C are 1, input A and C are 1, A and B are 1, and all inputs are at logic 1. Otherwise, it is at logic 0. Comparing it to Demo 1, they have the same logic because Demo 2 and Demo 1 have the same output. When we derive the Boolean equation based from the data gathered from Demo 2, it will be the same process with Demo 1.
And that's the end of this video. Hope you enjoyed and learned a lot from it. And have a nice day, and thanks for watching. See you soon.